Hi, welcome to GitHub Actions full course. This course is for DevOps engineers where they get hands-on implementation of CI CD. Let's see what you will learn part of this full course. Number one, what GitHub Actions is, why it's used, how GitHub Actions workflows, jobs, and steps work, and also understanding and utilizing variables, secrets, and inputs, transferring data between steps and tasks. You will also learn to use conditions and reusable workflows. Finally, we will implement CI/CD pipelines using GitHub Actions workflows. Let's get started. What is GitHub Actions? GitHub Actions is the service introduced by GitHub, which is typically used by DevOps engineers to automate their build, test, and deployment activities. One of the best aspects of GitHub Actions is that it does not require knowledge of any scripting or programming language. This service is gaining significant popularity and its usage has increased in the DevOps field for implementing CI/CD workflows. What is CI? It stands for Continuous Integration. It is a DevOps practice where developers regularly merge their code changes into a shared repository, usually several times a day. Each integration is automatically verified by automated builds and tests. And what is CD? CD refers to either continuous delivery or continuous deployment. Both practices automate the process of preparing code for production releases, but they differ in one key aspect. Continuous delivery includes a manual approval step, whereas continuous deployment releases changes automatically without manual intervention. Let's understand evolution of GitHub and GitHub Actions. GitHub was launched in 2008 as a web-based platform for hosting Git repositories. It was only a Git repository hosting platform that made collaboration easier through pull requests, issues, forks, and branches. But in 2018, Microsoft acquired GitHub and began transforming it into a fully commercial product by introducing services such as GitHub Actions. This is what our course is all about. GitHub Advanced Security, which helps in DevSecOps side. You can secure the applications by performing code scanning, image scanning, so on and so forth. GitHub Container Registry to store securely Docker images. GitHub Copilot, which assists developers in writing the code. Let's look at the workflow structure. Don't strain too much to memorize it at this point because we will go through several examples in the course and eventually these concepts will sink into the brain automatically. In GitHub Actions, workflow is created inside a repository. Workflow can have several components like when to trigger this workflow. For example, I want to manually trigger. I want to trigger on a PR. I want to trigger when Git push is performed on specific branches and so on. Inside workflow, we can create a job. This job should run on a specific runner. Runner is nothing but a VM or a piece of compute where this job is executed. GitHub Actions support wide range of runners, which we will see in a different section. To relate what could be a job in real world, a job could be a build job where bunch of activities to perform build. There could be deploy job, test job, likewise. Within same workflow, we can have multiple job declarations. Inside each job, we can have multiple steps. See, step is nothing but a piece of activity. For example, I want to run a command or I want to upload Docker images to Nexus. So that smallest activity is nothing but a step. In GitHub workflows, by default, all jobs run in parallel. So in this case, we have two jobs, right? These two jobs run in parallel by default. If you want to run them in sequential, we have a specific configuration to do. We will see those concepts later in the course. Likewise, we can have multiple workflows in a same repository. For example, I want to have separate workflow for build and test and separate workflow for deployment. That is possible in GitHub Actions. Let's go ahead and see Hello World program in GitHub Actions workflow. I'm in my GitHub account. Let me create a brand new repository. Let me choose the owner where I want to create this repository. I'm calling it GHA demo, meaning GitHub Actions demo. Create repository. After repository is created, of course, there is no code in this repository. In future examples, I'm going to take a project, either React.js or Java if possible. Even we can go with Java in some examples, React.js in some other examples. Click on Actions. In this page, click on Configure Simple Workflow. Remember, workflows are created inside Git repository in a specific folder, that is .github. Inside that, workflows, and inside workflows, a file. File name can be anything. Usually the extension is YML or YAML. Let me take off entire code because this is hello world example. I want to show everything by typing so that you have enough time to understand the concept. Let's give name to this workflow. I'm calling it hello world. In this workflow, the next step is trigger. When this workflow should trigger. GitHub Actions workflows supports various trigger options. For this example, let's go with manual trigger. Triggers are configured under on. Workflow dispatch, meaning we can trigger this workflow only manually. Then comes jobs. If you recall our explanation on complete GitHub Actions workflow structure, you can understand what I'm doing here. In a workflow, we can have multiple jobs. But in this example, I'm gonna have only one job. Give a tab space, provide name of the job. Let me give a random name. Name of the job can be any random name. Under this job, specify where this job should run. That is using runs on. We need to provide the agent, otherwise the runner, where this job should run. Let me go with Ubuntu latest. Later, we will discuss in detail about runners, different runners supported by GitHub Actions. After defining runner, steps, let's give name to the step and what this step should do. I want to run a echo statement. We should use run step. I want to print welcome to GitHub Actions. This is our first Hello World workflow. Commit changes, give a commit message. After it is saved, go to Actions and see the name of the workflow, that is Hello World. Click on it. You got the option run workflow because we are using workflow dispatch as an event trigger, which means we can trigger this job manually. So click on run workflow, choose the branch. We are having only one branch, that is main branch. Run workflow. This starts the job. Open the job. Job name is hello. Click on it. These are all built-in steps: setup job, complete job, but we have written one step, that is run step. In that, echo welcome to GitHub Actions, and this is the output coming from our first Hello World GitHub Actions workflow. In GitHub Actions workflow, you can run multiple shell commands in a single step. Let me show how to do it. And to reiterate, your GitHub Actions workflow files must be kept inside .github folder, which is in the project root, otherwise repository root, followed by workflows. This structure must be same. Inside workflows folder, we can have multiple workflow files, which we will see later. Now our focus is running multiple shell commands in a single step. Let's take the first example itself. Edit. This is the step, right? We are running only one command, but I want to show you how to run multiple commands. To do that, use pipe symbol followed by line 1, line 2, so on and so forth. Yeah, commit the changes. I'm committing directly to main branch. It will not automatically trigger because we configured workflow dispatch as a trigger type, meaning we should manually trigger this. Go to Actions, click on the workflow, run workflow, run it. Do a refresh and you see the workflow got triggered. Open it. There is one job. Job name is hello. In that one step, but we are running two shell commands. This is line 1, this is line 2. Now let's discuss how to create multiple jobs in a single workflow and how to run them. Let's go back to the code. Under workflows, Open the workflow file, click on Edit. We have only one job now, right? And the runner where this job should run, followed by steps. Let me take out entire stuff. I would like to type it because I want to give time for you to uh, understand, grasp the concept. Let's name this job a build job and say this: it requires runs on, meaning a job runs on a runner. Correct? It is mandatory field. For now, let's use Ubuntu latest. In later sections, we are going to discuss more about runners. For now, runner is, let's say simply, let's assume it's a virtual machine where this job is executed. Job name is build. It runs on Ubuntu latest. It has a single step. Job can have multiple steps as well. Now, parallelly, I want to create one more job. Let me call this test. So you can give any random name to the job, okay? Test. Job must have runs on. All right. Then steps. Later part of this course, I'm going to show real world CI/CD pipelines. So for now, we are understanding the fundamental concepts of workflow. That's the reason I'm going with echo commands. Okay. Now I want to create one more job. Let's name it deploy. Runs on. Specify where this job should run. I'm done with adding multiple jobs. If you notice, each job runs on its own runner. Commit. Give a meaningful commit message. Go to Actions. Click on the workflow. Run the workflow. Do a refresh to see that trigger. Open it. And see here, it is running all three parallel. Very important. Build, test, deploy. All three jobs are running in parallel. You have seen, right? By default, multiple jobs in a workflow runs in parallel. But in certain use cases, we want to run these jobs in a sequential manner. For example, I want to finish build, only then I want to do test. After finishing test, only then I want to do deploy. If that is the case, how to configure workflow? Let's see that. Go to the code, open workflow file, I want to run test job only after finishing build job. For that, use needs job name. I'm telling to run test job, it requires to finish build job. Likewise, to deploy the application, I want to finish test job. So I'm saying needs test. Commit the code. Go to workflow file. This is a workflow. Run workflow. You can see the difference in the representation in the UI. So it is first doing build, then it is running test. After test gets finished, it is running deploy. But if you see the previous trigger, this one, everything was in same line, meaning everything was parallel, right? And if you see the latest one, this one, job 1, then job 2, then job 3. Let me introduce GitHub Actions triggers. In GitHub Actions, triggers are defined using on keyword, which determines when a workflow should run. We can categorize triggers into 4 main types. Number 1, event-based triggers. Number 2, manual triggers. Number 3, scheduled triggers. And fourth one, workflow triggers. I won't go too deep into each concept just now, as we'll cover them thoroughly in the upcoming sections. This step-by-step approach will help you follow along more easily and build a solid understanding as we progress. Now let's practically see how workflow triggers work. I'll show how to use push as well as pull request triggers. First of all, let me clone this repository into my local laptop. Copy the URL. I am opening the terminal. I want to clone this on my desktop. I am using git clone command. CD into the repository. Here I want to open Visual Studio Code. Let's open workflow file. Let me take off unwanted jobs from this file. Alright, now I want to change on keyword. You know, right? Workflow dispatch means it is manual trigger. I want to remove this. I want to trigger this workflow on a push event because I'm not giving any specific branch details. So it can be a push from any branch. Let me stage changes, commit. Let me do push and see if workflow gets automatically triggered. Let's go to actions and see here. It is automatically triggered. So open, there is a single job and it's executing the step. If you want to specify multiple options for on keyword, let's say I want to trigger for push operation as well as for a pull request, I can mention it in this way. So it's going to trigger workflow for push event as well as for pull request event. Let me remove these details. Right, so this was how it was configured previously. See, let's say I want to trigger workflow only for specific branches, meaning when code changes are pushed into specific branches, only then I want to trigger. Let's see how to configure that. Let's say I want to trigger workflow only when changes are pushed into main, then I could simply say main. If I want to add more details, in this case, for example, I want to include develop branch and other branches, it is possible. Even we can use regular expressions like this. Meaning, it will also include branches beginning with release as a prefix followed by anything. Now let's see how pull request trigger works. Let me create separate branch for this demonstration so that I can create a PR and show how that trigger works. I'm creating a branch. Let us switch the branch. Let's configure PR triggers. It should be parallel to push. It is pull request. To specify branches like we did for push trigger, similarly we can configure for pull request as well. What does this mean is, when a PR is raised against main branch, it is going to trigger the workflow. Let's stage and commit these changes followed by push. Let's push this branch to remote repository. Let's click on pull request, new pull request. Our changes are in feature branch. Select that. Target branch is main. Create a PR. Again, click on create pull request. The pull request is created. Go to actions and see this. Workflow got triggered just now because we raised a PR. Let's open this. Open the job and perfect. The job executed successfully. We also can confine pull request triggers for specific activities. Let's say I want to trigger a workflow only when pull request is opened. Then I need to explicitly specify types. You can see all supported types here: opened, edited, uh, closed, reopen. You can check all those details in GitHub workflow documentation. So like we mentioned, the regular expressions for push, trigger, we also can specify similar stuff for pull request as well. Let's see how to create variables and use them in workflows. Variable holds a piece of information, or it's a configuration data, which can be used across multiple workflows in the repository. Usually we put non-sensitive data inside variables. If you want to store sensitive information like API tokens, access keys, secret keys, database passwords. We use secrets. Let's go ahead and create a variable. Go to settings, left hand side, scroll down, secrets and variables, click on actions, click on variables, repository variables. Let me put a dummy information here. I don't have a real example to put a real variable. I want to simply show how to create a variable, how to use this variable inside workflow. I am putting my name here, add variable. Likewise, we can put multiple variables here. Go back to the workflow file, open this blank.yml. Let's say I want to print the variable name. For that, we need to use workflow expression, that is dollar, double open curly braces followed by double closed curly braces. Inside this, it must be vars dot variable name. The variable name I want to access is my name. Commit, commit, go to actions. It is auto triggered. Open this workflow, open the job, and see this. It's printing hello followed by Hari Kamana. That's a value I stored in a variable. In previous section, we have seen variables, how to create, how to access variables in a workflow file. Now in this section, let us discuss about secrets. Secret is a sensitive information which should not be exposed to the outside world. For example, I want to build a Docker image and push this image to private Docker registry. I need password or API token for logging into the registry, then pushing image to that registry. Here, where we should store the password or API token, because it is sensitive information that must go inside secrets. So what happens? GitHub stores this secret and encrypts it. Even if you try to print secrets in a workflow file, it will mask it. It will not print as it is into the logs. Let's go ahead and see how to create a secret. Settings, secrets and variables, actions. It is a repository secrets. Click on new repository secret. Let me call this docker underscore password. This is not the real password. So now it is a plain text. After adding, that gets encrypted, and later we can't see that. Let me add the secret. Let me edit and see that it's not displaying the secret value. Let me copy this, go back to the code, go to workflows, open the workflow, edit. This is name of the secret. The prefix is secrets dot. See, for accessing variables, we used vars dot. For accessing secrets, we are using secrets dot. See, even though I'm printing, let's see how it gets printed in the logs. Commit. Because we have push event, right, it gets auto triggered. go to actions, see that this got triggered just now. Go to build, open build step and see it. It is masked. Right, so this is how we create a secret under repository settings and access secrets in a workflow file using secrets dot name of the secret. In GitHub, Action is a reusable application or set of code that performs a specific task within a workflow. For example, I want to check out the code, right? Where I provide URL, username, password, etc. etc. Now, this particular operation or task is performed almost in every workflow because we check out the code. If it is DevOps CI CD pipeline, then we do build, test, and other activities, right? Now, making this particular task as an action is very good option because we don't need to write same code again and again and again. In GitHub, action is pre-written, which is already written, available in GitHub Marketplace. Actions are configurable. It takes inputs, it also can give outputs. Let's go ahead and see how to use checkout action inside workflow. I'm inside the repository. For this demonstration, I want to create a dummy file because I want to show you how to check out the code. See, later in the course, we will take one real world application for all the examples. Now my focus is not on the real application. My focus is to teach you the concepts of workflow. Let's create new file. Let me call this index.html. Let me put a header. Commit. Just commit. Go to workflows. Open a workflow. Edit. Let me change few things here. Name of the workflow, the trigger when this workflow should run, jobs. I'm calling this action demo. Every job must have a runner where this piece of code executes. So here I want to show checkout action. Let's give a name. Check out the code. We use uses keyword for using action inside a workflow. The action name is actions slash checkout at the rate version of the action. You can find all actions supported in a marketplace. Let's search in the Google. This one, actions slash checkout action. Open it, and this is the code. In the README file, you can find details about how to use this action, right? This is the syntax. With keyword is used for passing inputs to this action. So let's go back to the code. Fine. I want to simply check out the current repository itself, nothing else. So I don't need to pass any inputs to this action. In the next step, I want to just print index.html and show. For that, let's use run. The command I want to run is cat index.html. Commit, commit, because there is auto trigger on push event. Go to actions, it got triggered. Open the workflow, open the job, and let's see this print step. It is printing. It did checkout of the code, because after checkout we have index.html file on the runner. I'm using cat and I can see the code. To understand GitHub Actions better, I want to demonstrate a simple use case, that is deploying a static website to an S3 bucket. Let's see what is covered in this video. Number 1, configure S3 bucket for hosting a static website. Followed by number 2, writing a GitHub Actions workflow to deploy the code from the GitHub repository to the S3 bucket. Let's get started. I'm in AWS console. Go to S3 bucket, create a bucket, give a meaningful name. Make sure you uncheck block all public access, because after deploying HTML code into this, we need access. Not only we, everyone over internet need access. Only then they can access this website. Remaining options keep default. Create a bucket. Yeah, check this checkbox. Create a bucket. The bucket got created. Now I want to enable static website hosting. This option, enable. Hosting type is host a static website. Index document, meaning when you hit this website, which file you want to serve by default. Usually we keep index.html itself. If something goes wrong in the website, if you want to show some error message, then configure error page details. This is optional. I'm leaving it. Save changes. And there is one last thing, that is S3 bucket policy. Go to permissions. In the bucket policy, I want to provide read access to everyone. In the background, I created this policy with help of ChatGPT. Save changes. This is part 1. We created S3 bucket. We made all the settings we need to do in S3 bucket for hosting a static website. Now the next part is, I want to create a workflow which takes the static website code from GitHub repository and deploy onto this S3 bucket. Let's go to my GitHub account. This is the repository I have, and there is only one file, that is index.html file. Go to actions. Just randomly pick any workflow, because I'm going to type the workflow from scratch. I'm calling this file static s3 deploy. Like we discussed earlier, the file name can be anything. Let's give the name of this workflow. I'm calling this deploy HTML to S3. Then tell when this workflow should be triggered. I want to trigger this workflow on a push event. Then comes jobs. Single workflow can have multiple jobs, right? In this case, I want to have only one job. I call this deploy. Each job must have a runner, meaning the compute where this job should run. I'm using a built-in runner. This runner is offered by GitHub itself, right? I'm using the built-in runner to perform this deployment onto S3 bucket. Then you must define steps. I'm using an action, which is checkout action. This represents the version of checkout action. This will check out the code from this Git repository. This must be a list. Yeah. After checkout, I want to send HTML code to S3 bucket. For that, GitHub Actions require permissions on S3 bucket. Let's configure AWS credentials. There is a built-in action to configure AWS credentials. This action takes few inputs. AWS access key ID. I want to fetch this access key ID from secrets. This is not yet configured. Let me first finish this workflow configuration. Later, we can go and configure secrets so that this action will work. AWS secret access key and the region. Let's find out the region of our bucket. This one. All right, let's go and configure AWS access key ID and AWS secret access key. Let's go to AWS console, identity access management. Let me create a brand new user. Next. I want to attach policy directly. I'm granting Amazon S3 full access. This is not recommended in real world. We need to create a custom policy and provide least permissions. But to keep this demonstration simple, I'm using Amazon S3 full access. Create user. Go to security credentials. generate access keys. I am going to use CLI in GitHub workflow for syncing code. Select the checkbox, provide description, create the key. Now go back, copy this, open settings in separate tab, go to secrets and variables. We want this for actions, not the environment secrets, the repository secrets. Give a name and provide access key ID. Add, create one more repository secret, and it is AWS secret access key. Copy secret access key, paste, add it. So once it is added, no one can see the secret. Now let's test this part itself. Commit changes. Commit, because we configured push event, it should auto trigger. There is only one job, that is deploy, and it is successful. Now what we need to do is, we did checkout of the code, we got access to AWS. Next part is copy static website code onto S3 bucket and see if it is deployed. Let's go to workflow file, edit, I want to use multi-line script. So I want to do AWS S3 sync. Whatever is present in the current folder, nothing but we did check out, right? It has index.html plus .git folder as well, remember that. So what I want to do is, I want to copy only index.html and exclude everything else. Let me fix this problem, put colon, yeah. And I did not install AWS CLI on this runner, but how it's going to work? The point is, Ubuntu latest runner by default has AWS CLI installed, so I don't need to install it explicitly. Let me commit this and see if it deploys static code onto S3 bucket. Commit, go to actions. Yes, it is triggered automatically. Yes, the syncing done successfully. Let's go back to S3 bucket. I did re-login. Let's go to S3 bucket. Open our bucket. Go to properties. scroll completely down. So there is a bucket website endpoint. Copy that. Perfect, right? So the application got deployed onto S3 bucket with help of GitHub Actions workflow. Before using environment variables in workflow files, first let's understand what is an environment variable. It is a key value pair stored in the system environment. Let me give one simple example. Suppose I have a script. This script connects to database. I'm developing this script. I want to test this in development environment. So this script connects to dev database. Its IP address, username, password, port numbers are different, let's say. Once I'm done, I want this script to be tested by testing team. So I need to deploy this script in the testing environment. Keep in mind the database details will be different in testing. Once testing is done, finally we move this script to production. There again, database details will change. So here, database details are changing. Now, how do I pass these details to my script at runtime? One way of passing those details to the script is using environment variables. Let's take a small example. Let me create a folder. Let's go inside this folder. Open this in Visual Studio Code. Let me create a script. In the script, I want to simply put echo statement. I will not complicate this script. What this script does, it reads environment variables and prints. Let's use echo. I'm using environment variable here and saying app is connecting to that specific environment. Remember, before running this script on any operating system, we need to set this environment variable. Without changing this script, we can change the environment variables. Again, going back to the database example I gave, I could read database IP, database port number, username, password for dev and connect to dev. And I can rerun this script by changing the environment variables pointing to test. Likewise for production. Save this. Let's get back to the terminal. I want to give execute permission to this script. Let's do it. To run this script, I need to first set environment variable. On MacBook, the way to set environment variable is export. Name of the environment variable is app-env because that is what we are using in the script. Equals, let me say dev. Now the environment variable is set to dev. Run the script. It's printing app is connecting to dev. Suppose I take this script, put it on test server. There, my script should connect to test database details. What I should do is, on test machine, change the value of environment variable to test and see it is connecting to test. Remember, I'm not changing the code inside the script. This is what environment variable is about. We can pass inputs to application at runtime. So when to use environment variable? If your application is using some information that is going to change from environment to environment, then you put it as a environment variable. Let's see how to use environment variables in a workflow file. Let's go to workflows folder, and I want to create a new file for this demo. It could be either YML or YAML. Let's write this workflow file. I'm calling this workflow env demo. Let's use on keyword for configuring the trigger. I want manual trigger. I'm creating a job env demo. So provide the runner where this job should execute. Followed by steps. Let's give a name. I want to use run command. For demonstrating the environment variable usage in workflow, I'm creating a dummy step which is looking for the environment variable. In workflow, environment variables can be configured at workflow level, job level, even at a step level. First, let's configure this at workflow level. I'm using env keyword followed by name of the environment variable, its value. What happens in the background, wherever this workflow is executed on that machine, this is set as a environment variable. And remember, I'm running a command and it looks for environment variable on that runner. Commit this, trigger and test it. Go to actions, env demo, run workflow, refresh the page, open the job, and it says app is connecting to dev. It's using environment variables successfully. I said environment variables can be configured at various levels. One is at workflow level. This is at workflow level. The other one is at job level. And finally at step level. Let's see how it works. Let me edit this file. Right? Now we have two environment variables with same name. I'm intentionally giving same name to tell you which takes precedence. Let me give this as test. One is at workflow level, other one is at job level, and let's see which one takes precedence. Commit the change. Go to actions, env demo, run the workflow. Refresh the page. Workflow completed successfully. Open the job. It's pointing to test, meaning if we have two environment variables with same name, one is at workflow level, Other one at job level takes the precedence. Let's go back and try to use environment variable at step level. So after name, let me say prod. Now we have three environment variables with same name at three different levels. Now the environment variable inside the step is going to take precedence. Go to actions, okay, env demo, run workflow, do refresh, open the workflow, open the job. You should see connecting to prod. So this is about using environment variables inside workflows. Let's see how to use inputs or parameters in GitHub Actions workflow files. To understand this concept, let's take a small example. Imagine there are three environments we have: dev, test, prod. I want a workflow to deploy applications to dev, test, and prod. We can better design this using a single workflow which takes inputs such as the environment to deploy and the artifacts to deploy. If there is no concept of inputs and parameters in workflow, we end up creating three workflow files, which is not a better option. Let's see how to use input parameters by creating a workflow file. Go to GitHub/workflows, create a new file. I'm calling this inputs demo YAML file. Let's give the name to workflow file. Let's configure the trigger. Keep in mind, if we want to use inputs, the workflow file must have only manual trigger. Under workflow dispatch, we must define inputs. Under inputs, name of the input variable. We need to configure bunch of options for this input variable. Description. Let's say choose the environment to deploy. Next one is required. Yeah, this is mandatory field. If I say required true, if it is optional, we can keep it required false. Then if required, we can configure default value. Let me make it dev. Let me go and show how input variables work. Configure jobs. Name of the job. We must configure runner for each job. Followed by steps. I'm creating one example step. Simply, it's going to echo the message. I want to say deploying the application to the environment selected by the user. We should use expression for that. It must be inputs dot name of the variable. The indentation issue. Yeah, commit this. Go to actions. There is some issue. Probably this is the previous one. Let me go to input demo. I'm choosing dev and running the workflow. I'm refreshing the page. The workflow got triggered. Let me see the print message. Of course, deploying the application to dev. I want to run this workflow file again by giving a different input. Let me say test and run the workflow. If you observe, we are using same workflow for deploying to different environments. We are reusing the workflow because of inputs. Right now it is getting deployed to test. Let me slightly change the workflow file. That is, I want the environment to be a list, not a free text like this. To do that, configure options. Now this was a free text. Now it has become a choice parameter. At the same time, I want to declare one more input, that is to choose the tag to deploy. It's also required. I don't want a default value, or let me say artifact tag. Let's assume this artifact comes from Nexus or ECR, whatever. I want to print deploying the artifact version to specific environment. Let's use the expression. It's inputs dot name of the variable. This space is optional, but for the sake of readability and consistency, I'm giving that space. Let's commit this file. Go to actions, open that specific workflow, inputs demo, click on run workflow and see this must be a choice parameter, right? Let me refresh and see that. Maybe this becomes choice after executing this at least once. Let me see that. Perfect, right? This workflow is taking two inputs. One is the environment to deploy and the specific artifact version to deploy. Still, it is not showing as a drop down. Probably I misconfigured it. Go to the code, workflows, inputs demo, edit. Yeah, I need to specify type choice. Do commit. Go to actions, inputs demo. Yeah, perfect. So let's say I want to deploy artifacts to production. Choose prod and specify that tag, the artifact tag to deploy. It's working fine. So this is the example usage of inputs in workflow. We had been using context variables so far in several examples. In this video, let's particularly talk about context variables. In GitHub Actions, context variables provide access to useful information about the workflow run, the event that triggered it, the GitHub repository, and much more information. Let's go back to the code. Go to workflows, add a file. See, the reason I'm writing entire workflow from scratch, you also get some time to understand the syntaxes. Name, context variables demo, the trigger. Trigger could be of any type. Let me keep it for a push trigger. Jobs. I'm calling this context demo. Specify the runner. Steps. I want to print few context variables. I want to use multi-line command. Let's say I want to print who triggered this workflow. Use workflow expression. GitHub is a built-in context variable. It's built-in. It provides the details about current workflow. There is one property inside GitHub, that is actor. This prints who has triggered this workflow. Let's say I want to print the repository name as well. Use GitHub workflow expression. GitHub is the context object here, followed by repository. Let's commit this because it's going to be auto triggered. It is. And see this. This workflow is triggered by Java Home Tech. This is how I logged into my account, right? The repository name is, this is my organization / GitHub Actions demo. Let's search in the Google for its documentation. Let's open this documentation. See here, GitHub context. This is the object, right? We use the github.actor. This one, the username of the user that triggered the initial workflow run. Likewise, we have env, the environment variables, vars, job specific context, right? Step specific context. We accessed secrets, if you remember, using secrets dot name of the secret. Let me show how to get this information programmatically inside workflow file. Let's open workflow file, edit. So there is a function to JSON, provide the object, you want to print that as a JSON. It must be inside workflow expression. It's going to print entire data context variables under GitHub. Commit the change. It gets auto triggered. So we are interested in context variables demo. The message is not clear, but let me check the workflow file. It's my bad. It should be echo followed by this string. Go to actions. This is the one we should refer to, context demo. And if you notice, it's printing entire information present inside GitHub context variable. So we can use this approach for getting information about GitHub context variable, right? Let's say I want to access the branch from where this workflow is triggered. I can use this one, ref name, go back to workflow file, edit, right? So here, go, GitHub dot name of that variable, ref underscore name. Let's do commit and check. Go to actions, context variable demo, open that. And if you see, the branch name is main. See, I have shown particularly using GitHub context variable, right? If you go to env, there are a bunch of options under env. So what happens, on every runner you'll find a bunch of environment variables. We can see what variables are present on that specific runner. Let me change workflow file accordingly and show what is present as an environment variable. Right here, add one more step. Use run. The command I'm executing is print env. Go to actions, context variable demo, open the job, this one, yeah, bunch of variables here, Java home, GitHub path, GitHub runner number, runner name, right? So GitHub ref type, so is it a branch or tag? If you want to access environment variables inside workflow file, let me show how to do that. Edit this file. So here, I want to print the GitHub SHA, means that latest commit ID, dollar. So this is environment variable available, and try to notice the difference. While accessing GitHub context variable, I'm using dollar double curly braces, and while accessing environment variable, the syntax is different. Dollar followed by the environment variable name. commit, go to actions, context variable demo, open that, open the job and see this one. This is latest commit ID in this branch. For example, we are doing Docker build and deploy. I want to tag Docker image with latest commit ID. We can leverage this option. Those kind of examples I'm going to show later in this course. Let's discuss GitHub Actions outputs. You can think of GitHub Actions outputs as a result written by one task which can be used in next task. Using outputs, we can share data between tasks and also data between jobs. Let's see how to use outputs in workflows. Go to the repository. Under workflows folder, let's create a new file. I want to name this outputs demo.yml. As usual, let's write this workflow file from scratch. Name it. Configure the trigger. I want this workflow to be triggered on a push event. Let's define a job. I'm calling this job 1. Specify the runner. Configure steps. Let me define step 1. It has to be a list. I want to define output in this step and access this output in next step. Echo. Let's say I want to set output. Its name is version and its value is 0.0.1. This is plain echo command, but I want to store this as a output. For that, use redirection to a special file in GitHub Action, that is dollar. This is a special file in GitHub workflow. Sending this information to this file is stored as an output. I repeat, we are storing output by name, version, value 0.0.1. Remember, I'm setting this output under a specific step. I want to use this output in the next step. Let me call this step 2. I want to say the version is, I want to get the output created by step 1 here. Use expression dollar double curly brace and close double curly brace. Inside that, let me show how to access output created by step 1. Steps dot, we need to provide ID of the step because I want to refer this ID in step 2. The ID is step 1. And coming to the syntax, steps dot step 1 dot outputs dot name of the output, that is version. That's all. Step 1, we are creating an output. Step 2, we are using it. So this is first use case of outputs. We are sharing data between steps. Let's commit this. Go to actions. Open this action. Now it is outputs demo. Open the job. I want to see step 2. We are able to access version which is created as an output in step 1. Let's move on and see how to share data between jobs using outputs. Go to the workflow file, edit this workflow. Let's take 2 jobs. Let me call job 1 is build. The assumption is this job builds an artifact and creates a tag. Let's call that tag is version in this case. We want to pass on this version to the next job, let's say a deploy job. Let's see how to share outputs between jobs. Let's say this is deploy. For the sake of simplicity, let me say uh, build step. We don't need this for now. And we have deploy job. Make sure the indentation is correct. It is wrong. Let me adjust this parallel to build. Every job must have the runner runs on followed by steps. But before we move on to deploy job and access the output created by job 1, I need to configure something else on build job. See, what we did in previous video, we created an output in step 1 and we accessed that in step 2. But in this case, I want to pass on this output to the next job. For that, what we need to do is, under the job, we need to declare outputs. Under this outputs, I want to say version. This name, right, is random name. You can use any name. It doesn't need to match with this output variable, not required. I want to initialize this version output at job level with this value. For that, dollar open and close curly braces. The syntax is again simple. Steps dot step ID, that is step 1 dot outputs dot name of the output. Here I am setting this output at job level. This is first thing we should do. And remember, we need this particular step as well where we are creating output at step level. Let me reiterate, build job is building artifacts with a specific version. That version I want to pass on to deploy job, which uses that artifact version to deploy. Here, steps, name, I'm calling this deploy the app. We're not really deploying the application. Our focus is how to share data between jobs using outputs. I want to say we are deploying the app with version, this one, which is declared at build, dollar, open, close, curly braces. Make sure deploy is started only after build job. Remember, in earlier discussions, I explained you in GitHub workflows, jobs run parallelly by default. If you want to make them sequential, we need to add a specific property, that is needs. Needs which job build, meaning to run deploy job, build must finish. To access output of build job, here it is needs dot name of the job, that is build dot outputs, under outputs version. Very simple. Commit changes, go to actions, open the workflow run. See here, build is getting executed, only then deploy started. Right, go to deploy and see deploy the app. Perfect. This version 001 is created by build job and we are using it in deploy job. This is how we use outputs for sharing data between jobs. Now let's see what are if conditions in GitHub Actions. If conditions control whether a step or job should run or not, based on certain rules or results from earlier steps. Let's go ahead and straight away start with first example. Let's create a separate workflow for this example. Go to .github/workflows, create new file, if demo yml. Let's give name of the workflow. I'm calling this if demo. Specify when to trigger. I want this workflow to be triggered on a push event for specific branches. For example, main and develop. Let's create jobs. I'm creating a job demo. Job must have runner. Followed by steps. Let me print some text. This is normal workflow file, but I want to run a specific step only on a condition. I want to use if condition. We can use if condition in a specific step, or we can use if condition at a job level. Here, I'm using a special keyword if, provide the expression which either returns true or false. For example, I want to run this step only when commits are pushed to main branch. Let's see how to put a condition. GitHub is a context object which we discussed in previous videos. This points to a specific ref, meaning the branch. I want the branch to be main. The format is refs heads main. Let me show this context object information from GitHub documentation. This one, GitHub. And notice this. The format is refs slash heads slash main. Let's come back. Let me add one more step. Let me change the name of first step. The second task name, I'm just giving run this step without any condition. The second step is running without condition. First step is running based on a condition on main branch. Let's commit this, commit changes, go to actions. Something went wrong. Let's see what is going wrong. The workflow is not valid. Unexpected symbol. Okay. There is a syntax issue. I'm assuming it's expecting single quotes. Let's commit. Go to actions. Now I don't see syntax issue. Open demo job. I did commit to the main branch, remember, and condition is true. It's running run if branch is main, and the second step should obviously run because there is no any condition on this. Let's go back to workflow file, edit the file. Let's say you don't want to use this complex format to compare the branch. There is one more property inside GitHub context object, that is ref underscore name. Here we can directly refer to a branch. Main, commit, finish the commit, go to actions, workflow got triggered, open the job. Yeah, still it's working. Previously we referred to github.ref. Now I replaced with github.ref underscore name, where it will directly compare with branch name. We have seen simple if condition. Now let me show how to use or condition, like condition 1 or condition 2. Let me create separate workflow file for this. Go to workflows, create file, copy paste it, or condition demo. Let's keep this trigger for push. Let me take out one step from this. Run for hurry or Java Home Tech, meaning I want to run this workflow if it is triggered by user hurry or Java Home Tech. Let's use context object for it. The context object is GitHub. Its property is actor. For using OR condition, put two pipe symbols. See, I'm writing this workflow file using Java Home Tech, right? This is the one. Let me change echo statement. And one more point, we're not using double quotes. We're not using the expression, which is dollar followed by double open curly braces and the expression in the end closed curly braces that we are not using. Reason being, if will by default evaluate this as an expression. Commit, go to actions, yeah, this is the one I want to check, or condition, go to demo. So it's not skipping because this workflow is triggered by Java Home Tech. It's matching the condition. It is executing this step. Let's see some more examples of using conditions in GitHub Actions. We are going to take two jobs in a workflow. One is build job, other one is deploy job. I want to run build job when a pull request is raised. And I want to run deploy job when commits are pushed into main. Let's go and see this example. For the sake of this demonstration, I want to create a branch. Create it. And the branch is also automatically switched. Go to workflows, create a file, name this build-deploy.yml, name of the workflow. I want to trigger this workflow for two events. One is pull request, other one is when commits are getting into main branch. First, let's begin with pull request event. See, under pull request, there are different types of events, opened, edited, the title, created, such things. But I want to confine this trigger only when pull request is opened and when the pull request changes are synchronized, meaning after opening a pull request, developers can make changes and push those changes to the source branch. That is called synchronizing pull request. Types. One event is opened and other one is synchronized. Go to jobs, build job, specify the runner, configure steps, let's test this code, commit changes, go to pull request, create a pull request, source branch is feature, base, the branch to which we are merging is main, create. After create, it should trigger the workflow. You can see that. Yeah, it is building it. Go back to the workflow file, edit. I want to introduce one more job, that is deploy. Configure the runner, configure steps, give a name, echo command deploying the app. I want deploy to run when commits are pushed into main along with pull request. I want to configure push event. Remember, I want this push event only on main branches, main. See, we have two types of triggers, right? One is pull request, other one is push. Let's say there is a commit push to main. It triggers this workflow. It's going to run build because there is no condition here. Plus it's going to run deploy. But our requirement is we want to run build only when pull request is raised. So we want to introduce condition at job level, that is if github.event name equals pull request. Now build job runs only when the event type is pull request. We need to add if condition for deploy job as well. If github.event name is push plus the branch name is main. Now if we raise a pull request, it should run build job. When we merge the pull request to main branch, it should run deploy job. Let's go and see that. So commit, do commit, go to actions, nothing got triggered, go to pull request, it is created. Yeah, there should be a trigger for pull request created. Open that workflow and see build job is executed, but deploy job did not execute. Keep in mind, because we created a pull request. Let me go and merge this pull request to the main branch. Then build job gets skipped, deploy job gets triggered. Go to pull request, open this pull request, perform merge pull request, confirm merge. Go to actions. Yeah, there is a trigger. Open that. See, build job is skipped, deploy job is triggered. Deploy, right? Build did not trigger. Before closing this, let me go back to workflow file. Let's say in this case, right, we are saying when pull request is opened or synchronized. But I want to limit this build job only when pull request is created to the base branch main. Let's say I want to add that additional condition in this. Go to edit, right? So after this, use double and github.event.pullRequest dot base dot ref equals main. This actually mean this is context variable. In that, event is a sub property, a sub object. Inside that, pull request base, meaning if pull request is raised to a main from a feature branch, in this case we are raising it to the main, only then I want to run this one. If pull request is raised to some other branches, it is going to be skipped. I would like to show one more example for if conditions using special functions such as starts with, ends with, contains, success, failure, and so forth. Let me give some context before I go ahead and write this workflow file. We want to use develop branch, main branch, and feature branch. When code is pushed to feature branch, it could be any feature branch, I want to perform static code analysis. When code is getting pushed to develop branch, I want to deploy to dev environment. And when code gets pushed into main branch, I want to deploy to the production environment. At the same time, if entire workflow is success, meaning all jobs in the workflow is completed successfully, I want to send success notification. If something goes wrong, I want to send failure notification. Let's prepare the repository for our example. I want to create one more branch, develop. Now we got main, develop. I'm going to create feature branch and start our example. Before that, I would like to clone this repository into my local and open this in Visual Studio Code. Let me close this, open terminal. We are on main branch. Let me check out develop. From develop, I want to create feature branch and start writing our code there. Check out -b. This command does two operations. Operation number one, create the branch. Number two, switch the branch. Go to .github workflows, create a new file, if with functions .yml. Name this workflow. Let me call this nice if example. We need to specify when this workflow should trigger as per our requirement. We want to trigger workflow for push event on specific branches. Main, develop, feature / star, meaning a branch name beginning with feature followed by anything. Let me close the terminal and please ignore the error you see here. Jobs. Let me call this quality checks. Configure the runner. Steps. Give a name. Use run and put echo statement. This is simple echo statement. But this job, right? We want to run on a push event. That too, if branch is beginning with feature. Let's add condition to the job. If I'm using a special function starts with, meaning it's going to take two arguments. The first argument, let's say feature / xyz, that is the feature name, and starts with feature. Obviously this returns true, but we don't want to hard code this, right? We want to get that branch name which triggered this workflow dynamically. So GitHub dot ref name. Using ref name provides exact branch name. All right. But one thing is, developers must follow this convention. That is, when they work with feature branch, they must prefix their feature branches with feature slash then their own feature branch name. To make this bit more robust, we can put uncondition and make sure the event name is push. GitHub dot event name double equals push. So this is the job we want to configure for feature branches. Then we want to have dev deploy job dev deploy runner is required. Let me name this step dev deploy, deploying the code to the development environment. Let's choose the condition for dev deploy. We want to perform dev deploy only when the event name is push and the branch name is develop. So in this case, I don't want to use starts with because develop branch name is going to be same all the time. So we are done with develop branch. Likewise, let's write one more job for production deployment. I'm calling this prod deploy. The branch name should be main. The event name should be push. Let me correct this typo. Production environment. All right. Now we are left with notifications. Okay. That is, if the complete workflow is successful, send success email notification. In case of failure, send failure email notification. Let me copy paste the job code. I'm calling this success notify. Runner is required. Step notify success. Success email sent to the team. Let's figure out the condition. Oh, there is one indentation issue as well. I fixed it. When this success notify should run. That is when the jobs in this workflow is successful. I'm using built-in function called success, but there is a problem. If I'm pushing changes to feature, only quality checks will run, meaning let's say it is successful, dev deploy, prod deploy or skipped. And also success notify must depend on above 3 jobs. Only then success notify should run. Otherwise, what could happen? Parallelly, success notify and other valid jobs could start. Success notify can finish faster by sending success notification. After a few seconds, the actual job could fail, right? So obviously, success notify must depend on all 3 above jobs. We must specify needs. and provide all the jobs it depends on. Quality checks, dev deploy, and prod deploy. Okay. So again, let's understand how this condition is going to work. For example, I am pushing changes to feature branch. This will run. Other two jobs will skip. This success will still return false because it expects all the jobs configured here is successful. If this is success, dev deploy is skipped, prod is skipped, this will return false. That's a problem. Let's see how to fix this issue. See, for any job, its state can be success, failure, skipped, cancelled. These four states. Let's replace success with always, meaning I'm telling my GitHub Actions, run this job always. Plus, I'm using AND operator, not failure. I'm using always and make sure it is not failed. It could be skipped. That's okay, but it should not be failed. So only then success notification runs. Likewise, one more job has to be written. Failure notify. Again, the dependent jobs are same. Change the labels here. Failure email sent to the team. Here, I can directly say failure. So that's all. Let's test this workflow. Open terminal. We are inside feature branch. Stage and commit changes. Push it to remote. Remember, we are pushing changes to remote, that is feature slash if example. According to our logic, it should trigger the job and it should run only this. Remaining things should be skipped. If this job succeeds, it should call success notification as well. Go to actions. Yes, it got triggered. Open that. See, quality checks are successful because we push changes to feature branch. That's why it is running only quality checks and it is sending success notification. From feature branch, I want to merge changes to develop branch. Then what should happen? Dev deploy should run and remaining two jobs should skip. If dev deploy is successful, again, success notification has to be sent. Let's try that. Go to pull request, compare and pull request. Yeah, a source branch is if example. I want to merge it to develop branch. Great. We don't have any events for raising a pull request. Okay, let me merge, confirm merge, go to actions. Yes, there is one more workflow triggered on develop branch. See, quality checks skipped. We already did this in feature branch, right? We don't need to do it again in develop and upper branches. So dev deploy is successful and success notification is currently running. It also working perfectly fine. And the last thing is merging changes from develop to main. It should do production deploy. Yeah, main, create pull request, merge, confirm merge. Go to actions. Yeah, there is a new trigger on main branch. Prod deploy is successful and success notify is also running. Let's test the failure scenario. In local, we are in feature branch. If I push changes to feature branch, quality checks will run, right? To test the failure scenario, let's use multi-line commands in run. One is echo, and I'm running exit one command. This indicates a failure. If quality checks fail, it should run failure notify. Git add dot commit changes, git push to the feature branch. Go to actions. See, on feature branch, the workflow is triggered, and see this one. Quality checks are failing. Because of that, it's calling failure notify. A reusable workflow is very similar to a standard workflow, but it can be called from another workflow. It avoids code duplication. It makes the code highly maintainable. For example, if you copy and paste workflow files at various places, let's say in future you want to make changes to that code, you need to change at various places, which is a maintenance issue. Let's go and see how to create reusable workflows. I created a brand new repository to keep this example simple and easy to understand. I want to clone this repository into my local. Let's run git clone command. Let me cd into this repository. Open Visual Studio Code. Let's close welcome file. Important to know, workflow files and reusable workflow files must be in a same location, that is .github/workflows folder. .github/workflows folder. Remember, it doesn't support subfolders. Let's create two workflow files. One is reusable workflow, other one is to call reusable workflow. Let's create reusable workflow first. I'm naming it reusable.yml. Provide name of the workflow. Then specify when this workflow should be triggered. Remember, it must be workflow call. Otherwise, we cannot make this reusable. Then comes jobs. Let's call this job name greeting. Jobs must have runner. Let's use Ubuntu latest. Steps. Greeting step. I want to use run. Let's say welcome to reusable workflow. Let's create one more workflow which calls reusable workflow. Let me copy paste. It must be inside workflows folder. Call reusable workflow. Let's trigger this on push event. Here I want to call reusable workflow. So what we should do is, we cannot define a job runs on steps like this. In place of this, I want to call reusable workflow. Let's define job name. I'm calling this call greeting. I'm referring to this guy here. Users dot slash dot github slash workflows slash reusable.yml. Right now, this reusable workflow does not take inputs. We'll see how to configure inputs in next example. Very important, we are not again declaring runner information because runner information is already defined inside reusable workflow itself. Let's commit these changes. Push it, refresh, go to actions, workflow got triggered, and see here. It's calling reusable workflow, and we see the output which is coming from reusable workflow. Now let's see how to configure inputs to reusable workflow. Go to reusable workflow. I want to configure inputs. Inputs. Input name is name. Description for the input. Specify if this input is mandatory. And also type. Now I want to use this input in my step. Here I want to say hi followed by the name given to this workflow, then welcome to reusable workflow. So dollar open double curly braces and closed double curly braces inputs dot name. This reusable workflow is taking name while calling this you must pass name. So go here with name. Let me give my name. Now commit and push to test this code. Click on Actions. There's a new trigger. It's calling that reusable workflow. Yes, it's taking my name and printing the message. In this video, I will show you how to create an Amazon EKS cluster using EKSCTL, install Argo CD on the cluster, access the Argo CD dashboard, and login. The prerequisites for setting up this is you must have AWS CLI installed on your laptop. You must have access keys and secret keys generated using AWS command line utility. So I have access key and secret key generated for my local laptop. You must have EKSCTL installed. EKSCTL is specially designed for managing Kubernetes cluster on Amazon. It's a command line utility which simplifies the setup of EKS cluster. In the background, it uses CloudFormation templates to provision the cluster. The command to create EKS cluster using EKSCTL is EKSCTL create cluster, provide name of the cluster, version, region, node group, nothing but group of EC2 instances where our workloads get deployed, node type, number of nodes, minimum nodes, maximum nodes. Minimum and maximum takes care of configuring auto scaling. Initially, it will set up 2 nodes. When the load is increasing, it can go up to 3 nodes. Let's execute this command. It takes up to 10 minutes to set up the cluster. I will pause the video and come back once it is ready. Cluster creation completed. Let's check the status using kubectl command. There are 2 nodes running. They are in ready state. After EKSCTL create cluster command finishes, it also generates access to EKS cluster in the background. Those details are kept by default inside .kube folder, which is a hidden folder. And if you see config file, it will have the access details for the Kubernetes cluster. Now we should install Argo CD inside EKS cluster. I am creating a separate namespace for Argo CD. Inside this namespace, let's install Argo CD. Argo CD is GitOps continuous delivery tool for Kubernetes that automatically syncs Kubernetes resources from Git repository onto Kubernetes cluster. Let's see Argo CD installation status. I'm running kubectl get pods inside Argo CD namespace. All are in running state. This concludes Argo CD is successfully running. Now we want to access Argo CD web interface, but by default the service created for Argo CD is cluster IP. I want to change cluster IP to load balancer so that we can use this load balancer endpoint to access from the web browser. Let's use kubectl get svc under Argo CD namespace. Argo CD server. This is the one we need to update. Right now its type is cluster IP, meaning it can be accessed only within the cluster. But I want to access this from my laptop. Let's edit this, change cluster IP to load balancer. kubectl, edit, service name, namespace Argo CD. Remove cluster IP and make it load balancer. Save and close. Now it creates application load balancer in the background. This takes few seconds. After that, we can access Argo CD from the web browser. Let's run a kubectl get svc command. We should find load balancer endpoint, copy that, put it in the browser. The load balancer provisioning is still happening. Let's wait for some time. Yeah, the application is ready. I refresh the page, click on advanced, click proceed to. We should see Argo CD web application now. Its default username is admin. I want to get the password, initial admin password. I'm going to use a command to get this initial admin password. I will put all these commands in the resources section. You can download and use it. Put the password and sign in. Let's walk through the code and manually deploy it from the local command prompt so you clearly understand each and every step. In the next video, we take this process further and automate it using GitHub Actions workflows. We already have a Flask Python application. When we send a request to the root URL, we get a message, "Hello from Flask on Kubernetes." Since this application is built with Flask, this dependency is added to requirements.txt. This application by default listens on 8000 port. If you want to change it, at runtime you can pass port environment variable by giving your own port number. Let's take a look at Dockerfile. We start with Python lightweight base image. We are creating work directory. This will create /app folder on Docker image if this folder doesn't exist already. We are copying requirements.txt. We are installing dependencies from requirements.txt. It has one dependency, that is Flask. We are telling this application listens on 8000. We are copying entire code onto Docker image and we are running this application using Python main.py. Let's manually build this image and push it to Docker Hub. Open terminal. Use this command, docker build -t, and before building and pushing Docker image to Docker Hub, you must log in. On my machine, I'm already logged in. For your reference, the command is docker login -u username -p password. This is the syntax. If someone is watching your screen and you don't want that guy to know your password, then better try this command. Docker login -u username. It will prompt for a password. So the password is not displayed. Login successful. Let's build Docker image, push it to Docker Hub. In order to push this image to Docker Hub, you must tag it accordingly. Prefix must be Docker Hub username, that is Kamana, slash image name I'm giving PyApp. Let's make this v1 as a version. Use dot. This is the current context Docker uses to build this image. Hit enter. Alright. Docker is not running on my machine, so we are not able to connect to Docker daemon. I'm opening Docker desktop. Docker desktop is running, so Docker daemon is active. Run docker build command again. It builds Docker image. Let's push this Docker image to Docker Hub. Docker push followed by kamana slash pyapp colon v1. Docker image is pushed successfully. Copy Docker image details. To deploy this onto Kubernetes cluster, we need deployment file and service file. I have written these files already. Let's take a look at deployment file. This is a typical Kubernetes deployment specification file. I'm giving kind, name, labels, replicas, match labels, so on and so forth. Change image and provide image details, the one we just pushed to Docker Hub. Container port, it listens on 8000. When we send this to Kubernetes Cluster API, it deploys 3 copies of PyApp application. After this is deployed, we want to access from the browser and see its response. I have created service file as well. Kind is service, name, labels. Make sure these labels are matching with, so this one here, the pod specification labels. I'm making this type load balancer. Target port is 8000, meaning when I send request to load balancer, it routes traffic to the pods that are listening on 8000. Let's open command prompt and deploy Kubernetes manifest files to the cluster. cd into Kubernetes folder K8s. Let me also check how many nodes are running currently. There should be 2 nodes running and they are in ready state. Use kubectl, apply command, provide path of the folder that contains service and deployment YAML files. We are already inside K8s folder. I'm saying dot slash, meaning everything in current folder. It created deployment and service both. Let's get the status. Let's do get pods. 3 pods are running. I'm sorry, they're not running, they're getting into crash loop back off. Let's have a look why it is getting into crash loop back off. Use describe command on the pod. It's able to successfully pull the image, but looks like something wrong with the application itself. Let's see the logs of the pods. We got an error exec format error. This is happening because we built Docker image on Mac ARM architecture and we are running it on EKS cluster. So this architecture is mismatching. Let's use docker buildx command and specify the platform for which we want to build this Docker image. I'm running it in a wrong folder, cd one directory backwards. Run this command. Let's push this image. Let's delete the existing deployment in Kubernetes. And let's create this again. cd into EKS cluster folder, that is K8S, kubectl apply -f, current folder. Service is already deployed, that is unchanged. It's creating just deployment. So maybe we again built a new Docker image with same tag v1 and the old images are cached on these nodes. It's using the cached images and causing same problem. Let's build Docker image with tag v2. Let's come back to root folder where Docker file is present. Build it. Push it with v2. Change it in deployment file. v2. cd into K8S folder. Now it has to use version v2. These pods are successfully running now. Let's get service details. Grab load balancer URL. Put it in the browser. We're getting a message, hello from Flask on Kubernetes. In next video, let's automate this complete process using GitHub Actions workflows. Let's start the automation of Python application deployment onto Kubernetes cluster. First, let's begin with CI automation using GitHub Actions workflow. Let's commit these changes into Git repository. Let's do git init. Let's stage changes. This is my mistake. I should do git init outside of Kubernetes folder, that is K8S folder. Let me remove .git hidden folder, come one directory backwards. This is our project root. Let's initialize Git repository inside project root. Let's create a repository in GitHub. I'm naming this GitHub Actions EKS. Create repository. Copy this command so we can map local repository with remote repository. So run git remote add command. So it maps local repository with the remote one. Let's push changes to remote. Refresh the page. We got changes. Let's write GitHub Actions for this application, a CI part. Let me pick the random option because I'm going to write everything from scratch. Let's name this workflow Kubernetes CI. I want to trigger this when there is a push on main branch. Jobs, PyApp CI. That's the name of the job I'm giving. Let's configure the runner, Ubuntu latest. Let's add steps. I'm using checkout action to check out the code from this repository. Let's build Docker image. Docker build. I want to push this image to Docker Hub. So I need to prefix it with my Docker Hub ID, that is Kamana. Let's give a name, GitHub Actions, PyApp, and the tag I want to provide here. I don't want to hard code this. I want to generate tag dynamically. Let's choose one approach for this. I want to pick the latest commit ID as a tag. When there is a change in code, it gets new commit ID, doc image gets new tag. Let's put double quotes. So in place of v1, I want to use built-in variable $GitHub underscore SHA. Let me commit and test our code. If it is working fine, and we will move on with next steps. Commit. Go to actions. Workflow got triggered. Open it. Yeah, it's doing Docker build. Yeah, so it's getting the latest commit ID. We are using that as a tag. I don't want this lengthy SHA. I want just 7 characters. That should be enough for us. Let's make changes accordingly in workflow file. So in this, yeah, I'm grabbing only 7 characters, using that for my tagging purpose. We need to log into Docker Hub. Only then we can push this image. There is an action for that, docker/login action. It takes inputs, that is username. I need to read username from GitHub secrets. Let's open settings in a separate tab. Secrets and variables. Click actions. I want to add repository secrets. Let me put Docker Hub password. For this, I need to generate a token from Docker Hub portal. Let's log into it. Let's go to settings. Let me check under my name. Yeah, account settings. Personal access tokens. Let's generate a new token. Let me keep this expiration 30 days. I want read and write both. Generate. Copy this token. Set it here. I want to add one more for username. This is my username. Add the secret. We want to use these 2 secrets in GitHub Actions workflow. The syntax is secrets dot secrets name. Password. Docker underscore password. Let's test this. Go to actions. Workflow got triggered. I want to make sure authentication is working. Authentication is failing. We need to fix this. Let me test this from my local to make sure I'm not doing any mistake. Let me copy the personal access token. I'm pasting it. Yeah, it's working fine with me. Let's check our workflow file if you're doing any mistake. Go to workflow file. Edit this. So Docker login action. Username and password. Docker Hub username and Docker Hub token. I'm updating the username to make sure I did not do any typo issues. Update it. So come back. Let's make it. I want to rerun all the jobs and see if it is still failing. Let's go back to workflow file. Okay, I think this must be double curly brace. Commit. Go to actions. Wait for this workflow to finish. Yeah, so login is working fine. So let's push Docker image to Docker Hub. Open workflow file. Edit. So after this, I want to update deployment YAML file with latest tag. I want to use a tool for updating a YAML file, that is YQ. I'm copy pasting that code. Install YQ. I'm downloading that binary and adding that to the path, giving proper permissions. So we can use YQ and easily update deployment YAML file. Run. Let's use multi-line script here. Yeah. So I'm getting the short SHA, which we used earlier step. I'm using YQ command. I'm telling to update a specific entry inside YAML file. Let's open a YAML file and I'll show that YAML file structure. K8s, this one, deployment.yml. I want to update this specific one. .spec .template. So dot means the entire document root. Spec .template .containers. This one. This is a list. We can have multiple containers, but we have only one. In that first container and that particular image. So this one we are updating. But we are building Docker image with a different name, right? So GitHub Actions Py app is the name. So I'm making sure the image name here is GitHub Actions -Py app. And location of the deployment file. So it is ./k8s. Inside ./k8s, this is the file name. Okay. And one more change we must do. We need to update this. I mean, the image name is not correct in the YAML file. Let's update that. Now it's going to change only this particular one. Yeah. So let me commit this. And we also should commit workflow changes. So commit and do the commit. So go to actions. It triggered two because we made two commits. One is for deployment YAML where I fixed the image name, and second one is I updated workflow file. Let's see what updates it's doing here. Okay, so but overall workflow is successful. The updated file I want to commit. Go to workflow file, edit. Because we updated deployment YAML, that has to be committed to Git. Because in next step what we do is we configure Argo CD, which is pointed to this repository. When Argo CD finds those committed changes, it picks those changes and applies those changes onto Kubernetes cluster. So after this, name commit deployment file changes. Let's use run and multi-command script. So we need to configure username. and also email. Git add K8s this file. Git commit. Docker tag updated by GitHub Actions. Commit changes, and let's test the workflow file. Workflow finished successfully. Let's see the deployment file if it is properly updated. No, this is not getting updated. Let's see if there is any mistake. Okay, I'm not pushing it. That's my mistake. Git push origin main. Go to actions. Yeah, open this. Wait for this job to finish and make sure it is successfully updating Kubernetes deployment file. Okay. Permission denied. We're unable to perform git commit and push. Let's see if there is any workflow permissions. Go to settings, actions, general, workflow permissions. Okay. So by default, workflow has permissions to read. I want read and write permissions in this case. Save it. Open workflow trigger. Open the job. And let's wait for this job to finish. Finally, it worked. Okay. Let's see if changes are updated. Oh, okay. So we need the value, right? We don't need a dollar short SHA. So let's fix this one also. Workflow file, edit. So we need to escape this string because right otherwise this is directly getting onto deployment YAML. I don't want this directly. I want its value. Let's do commit. I don't see any syntax issue. Job is successful. Let's refresh the page. Yeah, it is properly updated now. So let's move on to next video and prepare for CD. In previous video, we have seen how to build Docker image and update Docker image tag in deployment YAML file. Now, we want to deploy this onto Kubernetes using Argo CD. Argo CD is GitOps tool, meaning we can keep the state of the application in Git. That is used by Argo CD to deploy applications onto Kubernetes cluster. In our case, after building Docker image, we are updating deployment YAML file. So whatever changes we put in deployment YAML file on Git, those changes will be synced with Kubernetes cluster. Let's go and create new app. Let's give it a name. I'm calling this GitHub Actions demo. Project name, choose default, sync policy. Kubernetes has two options, manual sync and automatic sync. In case of automatic sync, whenever there's a change happening in a Git repository, those changes are automatically deployed onto Kubernetes cluster. Usually manual sync happens in 3 minutes duration. Let's go with automatic sync and come down. We need to select the repository URL. Our repository is GitHub Actions EKS. Copy this. Select the revision. I want to use main branch for deploying and choose the path. In the same repository, we have application code as well as Kubernetes deployment files. And what I want to do in this case, I want to give K8S as a folder, meaning Argo CD is going to check only K8S folder in the given repository. Only when there are changes inside K8S folder, only then it performs automatic sync in this case. Come down where it has to deploy. Of course, it should deploy onto Kubernetes cluster itself. Keep in mind, Argo CD is also running inside Kubernetes cluster. The cluster URL is this one. Select that namespace. On which namespace we want to deploy these changes. Let me put default namespace. So remaining options, I'm leaving as it is, create. Now, Argo CD uses the repository we gave. It picks files inside K8S folder and deploys them. If you go to K8S folder, we have two files. One is service, other one is deployment. We are saying 3 replicas, correct? Let's open this application. It has to deploy 3 replicas. Let's check that using kubectl get pods command. 3 replicas are running. Let's get service. There is a load balancer service deployed. Copy the load balancer URL. Go on to browser. Hit this. It might take few seconds to come up. It is deployed. Suppose we want to change number of replicas from 3 to 4. What we do is we make those changes directly inside deployment file. Let me edit, change 3 to 4, commit. It's populating automated commit message. Done. This triggers GitHub Actions. It's going to build a fresh Docker image, push that image to Docker Hub, update Docker image tag inside deployment YAML file. That is going to trigger Argo CD deployment. This is successful. And if you see, K8 folder is updated just now. This triggers Argo CD deployment. Usually, every 3 minutes, it goes to Git and checks for changes. We should either wait for up to 3 minutes or click on sync, which takes care of syncing right away. In real world, we don't need to really click this sync button. It's going to happen automatically. Let's run kubectl get pods. There should be 4 replicas. Now, let's change the color, which is going to trigger GitHub Actions workflow and Argo CD for automated deployments. Let's test it. Go to main.py, edit this file. Right now, the text is coming in black. Let's change the text color to red. Commit. Check actions. There's a workflow which is triggered. Workflow is going to build a fresh Docker image, and it's going to update the Docker latest tag inside deployment YAML. That in turn triggers Argo CD application deployment. Let's wait for a few minutes and come back and see if deployment is done. The sync operation is performed. Let's refresh the page. Looks like I made a syntax issue. Yeah, style should be color, and I want red as the color. Commit this. Now the entire process, building Docker image, deploying onto Kubernetes is completely automated. Yeah. So workflow is successful. Let's go on to Argo CD application. Either we should wait for 3 minutes because Argo CD goes to Git every 3 minutes, checks for changes. I don't want to wait, so let me click on sync. Let's run kubectl get pods. Yeah, there are newly created pods with latest application changes. Let's go here, do refresh, and perfect. It is successfully deployed.